So Janta, welcome once again to my channel Puzzle Pandit. I am Manoj Singh and today I am here with yet another Sudoku variant. This one is known as triple duty circles and uh, circles are mentioned in the puzzle name, and we can see that there are many circles there, yeah, and some in between lines there. So this puzzle is again a 3-star difficulty rating, that is a medium difficulty, and more than 90% of nice rating on the Logic Master site. So I thought this will be a very good addition into the channel. So let's read the rules. So normal Sudoku rules apply. That means each row, this is not part of row, each column, and then each 3 by 3 box must contain the digit 1 to 9 only once without any repetition. Shade some cells such that all shaded cells form a single orthogonally connected area and all unshaded cells form a single orthogonally connected area. No 2 by 2 region can be completely shaded or unshaded. The shaded cells are walls and the unshaded cells are paths. So why did I read all these things in a single as a single set? Because these are single set and these are normally called as the Yin Yang rules. What does those means is that we have to divide this grid into two parts. One is being shaded part and the other is being non-shaded part. So and how we do that? So for example, something like this will do, considering this is all shaded and the other cell which are not shaded are unshaded. So this could be something like this. So all unshaded. So any two unshaded cells are connected or using all the unshaded. And orthogonally means simply means they share an edge. So these two are not orthogonally connected. These two are not orthogonally connected, but these two are orthogonally connected. These two are orthogonally connected because they share an edge. So this could be one of the valid Yin Yang situation. As you can see, all the shaded cells. Shaded means whichever is in the pink color. So all those we can say these are the shaded cells. So as you can see, right, all these are connected, all the unshaded cells are connected, and as you can see, there is no 2 by 2 area which is fully connected, which is fully shaded or unshaded. So so now for example, if I put something like this, then this will be invalid because as you can see, this 2 by 2 area is now fully shaded, and as well as this 2 by 2 area is fully shaded, and we cannot allow that. Similarly, if you remove that, then this 2 by 2 area is now fully unshaded and we cannot allow that. So something like this is not going to be allowed. So that's the simple Yin Yang rules. Okay, and in this puzzle, the shaded cells are called as walls and the unshaded cells are called as path. The number in each circle, right now it is describing about the circle. The number in each circle shows the number of path cells, counting that one that can be seen from the cell circle. Walls block vision. Right, so let's take this one. This one we are saying that it is unshaded. That means this is on the path. So what does that mean is that this circle, the number inside this circle is the number of cells this is seen in the orthogonal area which are unshaded. So the value of this must be now 1 2 3 4 5 6 7. So value of this must be 7 because it is seeing the 7 cells, and because these two cells are blocked. Now imagine this is not there, right? And instead of that, how do we do that? Let's say instead of that, that's problematic, right? I wanted to have something right. If I remove this and instead if I put this, yeah, this is still connected, right? Yeah, so let's look at this. Right now this is orthogonally. Now this cell, there is connect, this is now what can we say, blocked by these two walls on the both sides, but here it is open on two sides. So the value inside this will be 4 because this 1 2 3 4 it is seeing 4. So that's what the meaning of this circle means. They are the digit inside that circle should be such that it's the number of unblocked cells or the paths is that it is able to see. So this must be 9 and also this must be 9 if the situation is like that. The number in each circle is the number of circles with that number in a circle. Okay, the number in each circle is the number of circles with that number in a circle. So this is like so this is also counting circles. Example is given, having a 7 in a circle would mean that there are 7 circles in the completed grid. So now we are seeing these circles. I mean, these circles are already there. We are not seeing that first time in the puzzle. But what they are saying, that if any of the circle is 7, that means we must have at least 7 circles, which should be at least 7 circles with the digit 7. So that is what this means. The other example, if we have any 4 here, any of the circle with 4, right? So then we must have also 4 circles, exactly 4 circles, not at least 4, not at most 4, exactly 4 circles with 4 digit into it. So this could be something valid situation for this. The sum of digits along a segment of line between two circles is equal to the sum of digits in those two circles, right? So this is now simply circle sum rules. What does that mean is that let me just get rid of this, and let me uh, use this example. So let's say if this is 4, and this is 5. So now the sum between these two must be such that it is the sum of these two. So the sum of these two digits must be 9. So this could be now something like 27, or this could be 180, anything, but the sum should be same as the sum of this. So now if this is 4 and this turns out to be 3, then this must be 7, because this is in between 2, and this sum should be whatever the sum is between these two. So those are the rules, and I think that's why these are called triple duty circle, because this circle has 3 meanings. The first is that they work as the vision for the paths. The second is that they are the counting circle. So any number in one circle, you must have those many numbers in the circles, or those many numbered circles. And the third is the sum of the digit, that is whatever the digits we are going to place in these circles, the sum of those must be equal to the sum of the lines joining them. So those are the rules. There is one more rule which is not included here, but which is important, that all the circles are on the path. Okay, this is quite obvious, but it is not given on the site as well as rule. But I think this is worth mentioning, that all the circles are on the path. So just remember that rule. I have added that in my description in the video, but unfortunately the author may have missed, or may have interpreted in some other way. I mean, maybe these rules can be interpreted in some other way, but I think that these rules should have been mentioned. So anyway, with that, let's start this puzzle. And before starting the puzzle, again I will request, if you have any puzzle you want to feature on the channel, or if you have any puzzle that you are stuck with and you want to know the proper path, please just give me a request, and I'll try to have it on my channel. So with that, let's restart this. So yeah, we may have to do some homework before starting this puzzle, because we are dealing with the yin yang. So now yin yang, for this yin yang, we are, sometimes it's called shaded, unshaded, sometimes it water and land, sometimes it's dark and light, but here now we are having wall and path. So wall we will have this color, and the path we will have green color. Okay, so green color will be path, and gray color will be wall. And as usual, maybe, or it's my habit that I mean, this will be named with the various color. I'll try to stick with wall and path, but sometimes I may call as a gray and green, and or sometimes I may call as shaded and unshaded. So please bear with me in that region. Right. So the first rule of the yin yang is that you cannot have this kind of arrangement where these two are of one color, and diagonal, opposite diagonal is on one color. And the clear reason is that whichever way you are going to connect these two orthogonally, there is no way you can connect these and this together, right? This green wall will definitely block that. So you cannot have this kind of, so this is called a checker pattern. So you cannot have checker pattern. The other thing is that this outer shade, right? It must be either is of all the one color, or it must, and if it is of two color, then there will be only one strip of each color. Okay, you cannot have something like this, where there is two strips of path and then two strips of wall. And the reason is again clear, that imagine this must be connected, right? The path must be connected. So if you connect the path, again you there is no way you can connect the wall to each other, so that's not possible. So that's why you must have at least some either entire grid, entire outer path with the single color, or at least maximum one strip of each color. So that's what that's are the two important properties of the this one, yeah, yin yang. Now coming to counting circles, right? The counting circles simply means that we have to count the number of circles. So yeah, counting circles. So let's count the number of circles. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So there are 14 circles. And counting circle basically what that means is that the numbers inside the circle should be such that they should sum to 14. That is the simple way of that. And if you check that if any number is there and those many number of circles must be there, then whatever numbers are there in the circles, exactly those many count of circles should be there. That simply means whatever numbers we are going to put into the circles, the sum must be the total number of circles. So the numbers we are going to put in those circles, those must sum to 14. And as we can see here, right, this is the maximum, right? 4. So yeah, so minimum you must have 4 different digits on this circle, and those should sum to 14. So minimum you should have 4. You can have more than 4, but minimum 4 should be there, because see, these 4 must be different numbers, right? So 4 different numbers you must have, minimum 4, which sums to 14. um, right. And for this puzzle it must be 4, right? Because if you have 5 uh, different digits on the circle, the minimum digits you can have is 1, 2, 3, 4, 5, which sums to 15, right? If you do 1 plus 2 plus 3, it sums to 15, and we only need 14. So that means in this puzzle we have exactly 4 digits in the circles which sum to 14. Exactly 4 digits which sum to 14. We know that now all the digits are in the on the all the circles are on the path. So maybe we can simply go ahead and put that like that. Uh, uh, okay. Now the simple thing, right? The circles are also doing the job of the vision, right? So the circles cannot have one. Now imagine this is one. That means including itself, it is only seeing one path circle. That means all these are going to be wall. If this is one, all these are going to wall. And now this cannot be connected to any of the path, right? And that is not allowed. That's not allowed in the yin yang. All the shaded or unshaded cells, or all the paths and walls should be connected. So that's not allowed, and that means that simply means is that the circle cannot be one. Oh, and now that becomes now we know the digits, right, in the circle, because um, now if the circles do not have one, and it is of 4 digits which sum to 14, those must be 2, 3, 4, 5, right? Because the least 4 digits that you can have excluding one is 2, 3, 4, 5. And what is the sum of those? That sums to 14, right? 3 plus 2, 5, 5 plus 9, 14, right? So 14. So this must be 14, because there is no other way. That's the minimum you can have there. So those are 2, 3, 4, 5. So that means we know that all these circles cannot connect that. Yeah, those are 2, 3, 4, 5. There is no other way. And that means in these circles there are 2 twos, there are 3 threes, there are 4 fours, and there are 5 fives. Um, all right. This is in the corner, right? So one of these must be dark, right? Or one of these must be wall. Otherwise, um, if there is no wall here, right, all these must be path, and then this is 2 by 2 area, which we cannot allow. So that means one of these is wall. And now look, what does that mean is that all these must be path, because now because we have at least one wall here, and we cannot allow 2 strips of wall. So this all must be green or path. Now by the 2 by 2 rule, this should be wall. Now we don't know that, right? This should be now wall. Now to avoid the checker pattern, right, this must be path. Now this cannot be 2, right, because this is seeing at least 3. Right. In fact, look at both these numbers, right? This is maximum 5, and now this is even block for this. So maximum it can go is 1, 2, 3, 4, 5, right? So from here onwards, it's definitely going to be, yeah, it's definitely all wall. So at least up to here, it's definitely all wall, because this is maximum 5, this is maximum going here. And once the wall starts, you cannot have any of the path, because then that will be two strips of path which we cannot allow. So from here to here, definitely it is going to be wall. And same thing here, right? This is 5. Um, this is already 3. No, this is already 4. So that's not 4. That's not 2 or 3, 4, 5. This is already 4. So maximum this is taken or not taken, but whatever. So maximum this could be taken, and that means all these are wall. So yeah, so we got lot of walls here. That means that has to be now path to avoid 2 by 2. That must be wall to avoid this 2 by 2. That must be path now to avoid this 2 by 2. Um, that must be now path, right, to avoid the checker. These two walls should come out, right? This should be wall now to avoid this 2 by 2. These are not 2, right? This must be 3. This one, 1, 2, 3, 4. This is not even 3. This is 4, right? 1, 2, 3, 4. And now 1, 2, 3, 4, right? Now this must be wall, right? Because imagine if this is path, then this is 6, right? 1, 2, 3, 4, 5, 6. But we do not have that number here, and that means this has to be wall, and this is 1, 2, 3, 4. That's 4. What am I doing? That's 4, and that means that's not 4. None of that's 4. None of that's 4. Let me disable the pencil mark. Yep. So none of that's 4. We can have that number. We know that this is sum of these two, so that could be now either 7 or 9. But I don't think that is going to be useful now. 4. So 1, 4 is done. These two are 6, 7, 8, 9. Let's just put that, because even though, see, 2, 3, 4, 5 is done here, right? And now the sum of this minimum should start with 4, right? Because 2, 2 will be 4. But 4, 5 is already gone. So these are minimum 6, 7, 8, 9. So that could be 2, right? These both could be. Oh wait, that cannot be 2, right? Both these could not be blocked, right? Because then there will be checker pattern. So that cannot be 2. At least one of this must be. In fact, exactly one of this must be this thing, wall. So this has to be 3. Can I say this has to be 3? No, not necessary, right? I mean, it may possible, right, that this is path, this is wall, but then this could extend here, and similarly it could extend here. So that's not necessary that this is 3. The only thing we know that is that one of these must be wall and one of these must be path. Three, 4, 5, 2, 3, 4, 5. Now if that's connected, mm, 3, 5. So now it is either like this, or these both are joined. It's not possible that only this is block and this is path, because of this 3, 5. uh, 3, 2, 3, 4, 5, 4, 5, 3. What next now? 3, 4, 5, 3. If that's 3, that is block. Can that be 2 is the question I am thinking about. These both will be blocked, and this will be all this will be. If that's joined, then this is minimum 3. Or even if this is joined, or this is joined, this cannot be 2, right? If this is joined, this is 3 or 5. 2 will be gone, so this is 3 or 5. One of these will be 3. No, if this is joined, then this will be 1, 2, 3, 4. Oh, and then you have to join this, which will then go beyond 5, right? Right, so this is not path, right? Because imagine if this is path, what is the value of this? Is 1, 2, 3, 4. So this is more than 4. And now to make it more than, but 4 is not there, so make it 5. We have to now connect to this, but then it will suddenly become 6. So if this is path, you do not have any value for 6, so that has to be wall. That has to be wall. So now it can only grow like this. So this could be wall. Now if this is connected, 3, that will be 1, 2, 3, 4. This will be 4, this will be more than 4, which will be 5, and this is not possible, right? Right. Now imagine this is path, right? If this is path, what is the value of this? This must be 5, right? Because 1, 2, 3, 4, 5 here, right? But then what will happen to this? This will also be 5, right? In fact, then that is not possible, because then both these will be 5, maximum both these will be 5. So that is also blocked. And now we know that value of this is 2, but more than that, we know that this is also now wall. Now what is happening? So that's 2, that's not 2, that's 3, 5. Oh, that's also 7a, so we got pair of 7a. So what is this now? 3, 5. These both are not. Oh, 3, that means oh, so only these two are connected, right? This cannot become 5 now. 1, 2, 3, 4. The moment you connect this, right, it will connect to this. So this value must be 3, and it must be connected this 2, isn't it? There is no way this could be 5, right? 1, 2, 3, 4. But the moment you connect this will become 6. 1, 2, 3, 4, 5, 6, right? So that value is 3, and the only possibility is here, and that is block, or that is wall. Now this must be path, right? Because this is path, and now this is 5, right? 1, 2, 3, 4, 5. That's now 7, right? 5 plus 2, 7. That's not 7. None of these 3 now, right? This must be now wall to avoid the checker pattern. Mm. Mm. One, two, three. Mm. I'm thinking if this is kind of limited, right? Because if this is taken, if this is path, this will become. I mean, if this is wall, all right, then to have 3, it must be like this. Wall. Nope, nope. And if this is connected, then to have 4 or 5, you can have something like this. Hmm. 5 to. Wait. This sum, right? So this is. So that can't be 3 here now, right? Because this is not 5. This must be 3 plus 2 and whatever this is. So that can't be 3. So this is 4 or 5. This is 4 or 5. And that means that has to be 3. None of that's 3. Now we got 1, 2. Now remember, we must have only 1, 2 from remaining circles. And only 1, 3 from remaining circles. So now that becomes 3. Yeah, that means whichever is this, it is stopping here. Mm, I don't know, but where it is stopping. Uh, Now this must be connected, right? Because now to minimum have this 1, 2, 3, 4, and then this will directly become 6. So this has to be connected here. And to 4 means this is minimum connected, right? And it means that has to be wall. This should come out, so that's wall. One of this is wall, but we don't know which one. Uh, that now cannot be. That could be 6. That cannot. Oh, this has to be 4 now, right? Because the option of 7 is not possible. 5 plus 2 7. So this has to be 6. This has to be 4. This has to be 5. 1 2. So this is 4, right? 1 2 3 4. But it could go here or it could go here. Sure. Uh, Now we know that this must go out, right? So, but where will this will go out from? In fact, this is 4, right? So we know that this is taken. That's the simplest way. So this is going out from here. And now that must be to avoid this 2 by 2, right? This must be path. So now that 3 is complete, right? So that cannot be there, and this 5 is also complete, right? So this must be wall. Now that to avoid this 2 by 2, this must be this. To avoid the checker, this must be path. To avoid now 2 by 2, this must be wall. This must be what? To avoid 2 by 2. This could be anything. How come? No, no, this must be wall now, right? Because this needs to meet this. So this is wall. Mm. Now look, 2 is not possible here. In fact, one of this is 4 and one of this is 5, which is going up. But we don't know which one is going up. So something like this when happens, right, in Yin Yang puzzle, there are two circles. There are two vision circles which are on same line, right? So one has to go up, otherwise both will be same. One has to go in some other direction than the direction that they are looking at. So one of these has to go up, but we don't know which one. Most probably looks like this, because even if this is going up, this could meet here, right? After going up. And I can't see any pattern also right now. 3 2 4 5 2 4 4 5 4 5. Now this is 4 2. Hmm. That's sum to 9. Hmm. One of these is going up. Oh, this should now go up, right? This should meet someone, so that has to go up. Okay. Now this could come down, or this one. This is confusing. Not confusing. I mean, we cannot figure out what this is. This could be both. Yeah. To avoid now this checker pattern, this must be. Now we know that this must be 4, right? 1 2 3 4. And that means that's 5, and that means that has to now go up. And now this has to come out, right? Now what? How many 4s are done? 1 2 3. 3 4s are done. We want only one more 4. 1 2. 2 3s are done. We only want one more 3. That guy is 3, right? 1 2 3. That is 3, right? That was there. 1 2 3. So 3 are done, right? 1 2 3 threes. Remember, these circles must have exactly 3 threes, and we got 3 threes. That means that's not 3, that has to be 5. That means that's 9, that's 7. That 7 we could easily figure out from here. um, but anyway, 5. That is now blocked, right? Because this is 5. That was simple one. uh, Still not giving up. 4, how many 4s are done? 1 2 3 4. We only have one 4. Right? That's not 3 now. 1 2 3 1. So that has to be 4, right? Otherwise, if this is 4, this will be 5, this will be 4, right? That has to be 4, isn't it? 2. Oh, we also need one of 2. Sorry, I forgot that. We also need 1 2. The problem is that's 4. No, that's possible, right? This could be 5, this could be 2. Sorry, I'll take that back. That this must be 4, I'll take that back. That's not necessary. Even this could be 4, this could. I have forgot about 2. We need one more 2. Okay. Uh, so what is happening now? Oh, that's not 4 now. Now look. Now if you join these two, right? If this is not 2, this is 5. 1 2 3 4 5, and that will be 5. So that will be now more than 5, right? That has to be more than 5. 1 2 3 4 5. So if we join these two, that will be 5, and now this must be more than 5, but which is not possible. That means this is 2. This is 2, and that means that has to be wall. And that's not 2. That's 4 or 5. Now that's minimum. That can't be 2 now, right? We have done with both the 2, and now this has to be 4, right? This is both blocked by wall on both the sides, so that has to be 4. And that has to be 5, and that is now sorry, that is now path. And we have done all the coloring. This is remaining, surprisingly. Yeah, this must meet, right? This path must miss somewhere to make it joint, right? So now all the path is joined, and all the walls are joined. Yeah, that's fine. So I think this is so coloring is done. Now what normally I do is that just change it to a little bit lighter colors, so that you know I don't get a little bit confused while putting the colors. Otherwise, if the colors are dark, right, sometimes I get it difficult to scan the colors and to do the Sudoku. So now this is, so we all the single we can do, right? So this is 3 plus 3, which is 6. This is 5 plus 3, which is 8. Any other single guy there? Nope, all the singles are guy as well. So that is 1 8 9 now by Sudoku, right? 1 2 3 4 5 6 1 8 9. That's not 8. That's 7, right? That could be 3 4 or 1 6. Let's just put that. That could be 3 4 or 1 6, but that's not 3. That means that cannot be 4. 4. 4 is one of these two. 4 plus 4 8, right? That's not 3 5. That's only I can say. So that's 2 6 and 1 7. 3 3 is here. 3 3 3 is here. That's 9, right? 9 is no. That's not 1 8. That's not 4 5. It is either 3 6 or 2 7. But that cannot be. Oh, that cannot be 2 7, right? Because of this one. So that's not 2 7. That's 3 6. So that's not 2 6 now. That's 1 7, right? 8 1 7. 1 7 2. 2 is not here. 2 is not here. 3 3. Just give me 1 second. Okay. So we were just filling out the entire grade, right? So that's 6. Now this is 8, right? Without 3 5. So that's 1 2 6 7, right? Okay. That's not 6. That means that cannot be 2. This is 7, so that must be now 1 6, right? But look, 1 7 1 7, so that has to be 6, that has to be 1. That 6 is not doing anything, but that 1 is remaining, removing 1 from here. Uh, these are these two numbers now. That must be 2 9. But look, 2 is looking at here, so that must be 9, that must be 2. Mm. That's 9 without 3 6 and 4 5, so that's again 1 8 or 2 7. But that cannot be 8 by Sudoku, so that cannot be 1. 8 is looking at this. 1 7 1 7 3 6 8 9 1 9. Hey, that 9 is looking at that, right? So that must be 8. Uh, that can't be 8. So we got 1 9 pair here. Should could have been in single box. But anyway, we'll take whatever we have. 3 6. Nobody is looking at this 6. 6 is not here. 6 is not here. 9 is not here. 9 is not here. So we have filled everything, right? Or maybe this one. This is 9, right? And 4 5 is not possible. So that's 3 6, 2 7 and 1 8. But look, that cannot be 2. That means that cannot be 7. That cannot be 6. That means that cannot be 3. And again, that cannot be 1. That means that cannot be 8. So I got 1 7. Oh, is this triplet or something? 1 6 7 1 2 7 1 2. No, 3 is here. So no quintuple or quadruple or anything like that. If 5, have I put 5 accidentally anywhere? Nope, I didn't. So what now? It's just Sudoku now. 5, where is 5 here? 5 is not here. 5 is not. Oh, 5 is not here. So 5 is one of these two. 5 is not here. 5 is not here. 5 is one of these two. Not 6 5. 5. Oh, that's 5 now, right? That's naked 5. 5 5. Yeah, that's 5. That's 5. So is that 5 helping anywhere? Nope. So only these two 5 remains, right? Okay. 1 7 1 2 7 1 2 4 7. That's not 7. So that's 1 2 4. Let me just put that 1 2 4 7. 3 we have put, right? 3 3. That's not 3 for some reason, because that can't be 6. So 3 is here or here. 8 is one of these. That's all 8 we have. How to go about this now? 1 1 1 is one of these. 7 is one of these. 7 is also here. That should sum to 9. That should sum to 9. This 9 we have already put. 3 3 6. I'm just looking at anything that I have missed. I don't think I have missed anything. No, I didn't miss anything. 6 is in 3 places. 6 is not here. 6 is not here. 6 is in 3 places. So what is happening now? Maybe something around this middle box. Oh, these 3 digits, right? So that should be pencil markable. 1 2 3 4 5 6 1 8 9, right? What? Just at least give me something. Nope, all are possible. 1 8 9. Nobody is looking at anything. Okay. 1 8 9 1 8 9 1 8 9 2 3 8 1 8 9 1 8 9. All right. 2 is one of these two. 1 9 1 9. At least if I get this 1 9. 9 is here. 9 is here. Right, what kind of standard Sudoku is this? This is all 1247, right? 17127, 1717. These four digits, right? Maybe this one. That's not one, two. That could be three, four. Cannot be five. Cannot be six. Cannot be seven. Cannot be eight. That's only three nine, right? Okay. 3919. Doesn't matter that much. Five is here or here in this box. Oh, five we already know, right? It's only here or here. So what's happening now? One is here. This is seven, right? Five to seven. This is seven. Yeah, I already put, right? One six or three four. One six or three four. So if this is one six, that will become seven. That will become two. No problem there, right? That will be three. That's fine, right? Mm, yeah, that's fine. But if this is three four, that will be three. That will be four. That will give this digit six and three. Now I'm confused now. How to move ahead in this? 3617 8. I am looking at everything, right? Yeah, 7 I have done, 6 I have done, 7 I have done, 9 I have done. Hmm. I'm looking at the same things again and again. This is only 3, 4, 5. Where is 6 in this line now? 6 cannot be here. So 6 has to be here or here. Hmm. That's 6 now, right? Because this cannot be 6. 6 is looking at this. So something is better than nothing. So that's 6. That I will take happily. Uh, so 6 is not here. Right, in this 6 is now here or here, right? Okay. So 6 are done quite nicely. 6 is already here. 6 will be here. Okay. That's not 6, right? So that's not 1. Okay. 1346 is 46. 13 doing something. 133619. No. 46 doing something. 46. Nope. I thought 6 will give a lot of things, but it didn't. 6. We are able to put 6 here. If that's 6, that's 4. Again, I'm going again and again to the same thing. Okay. Uh, One eight nine, 189, 189. Okay. Oh, these two digits, right? Now because we got 6, right? That must be now 1, 2, 3, 4, 1 and 8. Can I say that this is 1 and 8? That's right. So now these three digits must be 1, 2, 3, 4, 9, 3, 4, 9. 1, 8, 3, 4, 9. Not helping that much. This one is now 2. Nope. What is happening now? 1346, 1336, 1946, 1946, 519. Am I missing something? Sometimes you solve this so fast that you surprise yourself, and sometimes it is so slow that You doubt yourself. Uh, 49189. This color, I am going to change this color. What can I change this to? Maybe make it dark. No, dark. I don't like dark. Because I am worrying that I am not seeing these lines properly, and I am missing some of this information. Uh, 127167. A lot of digits have been put here. Is anything missing here? Nope. We have 1. We have 2. We have 3. Oh, we do not have 4 here, right? No 4 here. So 4 is either here or here. That's 4. That's 4. That's 4. If that's 4, that's 4. 4 will be one of these. 4 will. Wait, where is 4 here? That 4, right? That is a simple way to put that, right? That's 4. So right now 4 is not here. That means that has to be 4, right? So in this column now where is 4? I don't see any 4 here. So that has to be 4, right? So now that has to be 4. We can remove 4 from here. That 4 gives that as a 4. That's not 4. We must have done lot of 4s. In fact, we have done all of 4 except this. So that has to be 4, and that 4 means that has to be 3. That 3 gives 6 here. That gives 3 here. 3 3. Now 3939. So this has to be 3 now. 3 is here or here. There is no going back there. 167238. If that's 3, that could be still anything. 4 we have done, right? Everything. So now what is remaining? 1278. 1278. 8 we didn't look at, right? Or 9. Also now 9 is only here or here, right? And 9 here is not here, 9 here is here, right? See, 9 is not here, and because of 399 is not here. 9 is one of these. That means 9 cannot be here, and that means 9 is only here. So now that's not 9. We know that this cannot be 9. This must be 9. That's it. Okay. That is 9. 9 is not here. That is not 9. 9 is here, right? And that means that has to be 9. Is that 1 to 9? So 2 and 9 is here, right? So what is the remaining thing? 7. Is that only 1 and 7? But 1 is there. Can I put 7 there? So let's do the normal 1 2 3 4 5 6. Yeah, 7. That's 7. All others are right. 8 9 is there. So now 7 7 7 is one of this. 7 is not here. These 3 digits now 238, isn't it? I just put that 238 and now do the reductions. That cannot be 3 because 3 is looking at here. 238. This could be everything. Unfortunately, yes. One of these digits is missing. 189. 1289, right? 1289, but that's not 89, right? Because 89 both are looking. So that's 12. 1217 127. So that's fine. 17. That's 39. So where is 3 in this box? Either here or here, right? And similarly, it could be here also, right? In this line. maybe 3 will help us. 3 3. Nah, 3 is here 3. Okay, 3 is, oh, 3, right? No, 3 we have already done here. Sorry, my bad. I thought 3 is in line, but it is in circle. uh these two digits, right? 5, it is clearly written here. Pencil mark 5 and 8. Now 5, right? So that has to be 5, right? I remember some pencil marking of 5. Suddenly I am remembering all the pencil marks. So now these two digits are now 1 2 3 4 5 6 7. This has to be 6 7 now, and that's 129, right? So that's 19, that's 129. um, that's not 9, right? Because this 39 is there, we know that. So 1219 129 67 18. 391867 is 1267, right? Hmm. Come on, man. We're just doing progress, but a little bit slow progress. Look, this must now need 167 and 67 both are looking at. So that's one. That's not one. This is 6 7. And even 6 is looking at that. So that has to be 7. That has to be 6. Now this 6 must give this 9, right? This must sum to 9. So that is 3. Uh, that's not 7, and that's not 3. This 3 must be doing something, right? Now 3 just going 3 just giving 3 here and here, but that means that is not 3. 28189, something is wrong here. 2, that's not 1 now because of this one. So 288939, that's fine. 2889, right? These 3 digits now must have 1 1 2 3 4 5 6 1 2 7 8, right? Wow, it's not reducing to anything. Okay. 6 and 3, this is also oh, this is not 6 now, and if that's not 6, this must come to 8. That cannot be true. Yeah, this is 1717. That will do a lot of things, because that will make this as 8, that as 1, that will make this as 7, that as 6 7 6, that as 7. uh, and this will make now that will remove 1 from here, right? Because of 1 7, that's 2 9, that's 2 9. And these are now 1 2. Oh, that 1 is giving this as 2, right? That's 2, so that's 9, that's 1, that's 2, that's 9. What are these two digits now? 1 2 3 4 6, but look, no, 4 is already there, sorry, my bad. 6 8, right? But 6 is looking at it, so that's it, that's 6. um, so all the 6 are done, I guess, right? 8. mm, so that's not 8. uh, 127, that must be now 127, right? 127, unfortunately nobody is looking at this. So now what is happening? 1717 1717 127. Come on. Oh, that 2 is looking at this, right? So that's 8. No, now that's 8. That 8 will give, that 8 must give 2 here. 8939, that is 389, right? But 9 is looking at this, so that must be 38. 3989 38, that's fine. 127 is done, so what is that now? That has to be 38, right? 38. 1289. This is one single number, right? That's not 2, that's 17, right? 17 17 127. Something should remove from there. 127, this is 9, so for 1 it is 8, so either 27 or 18. Yeah, I think it cannot be 2 7, right? Because 2 7 will give 1 year, and that is not possible, right? If you look that, if this is 2 7, which sums to 9, that will be 1, and that is not possible. So this is not 2 7. This has to be 8 1. So that's it. That's 1. That 1 will give 7 year. That will give 1 year. That will remove 1 from here and here. That's 7. First that will. That's simply 9. That's simply 8. That's simply 1. That's then 2. This is not. This is 9. No, right? 1 1 7 1 7. That is 2. That is 7. That is 1. That is 2. 8 gives 3 year, gives 8 year, and 3 in the corner, so we are on the right track. 1 gives 7 year, that gives 1 year, that is 7 year. Oh, okay, this is remaining. I thought I got scared. I thought I've completed the puzzle, but still the message didn't come. So that's 3. And now we have solved the puzzle. Okay. Yeah, so this was an interesting puzzle. Actually, I thought that after putting everything, let that I'll be able to solve, but no, the standard Sudoku was difficult here. Uh, I don't know how can I do the color thing. Oh, now it is just giving me. Oh, maybe if I go into the color, maybe it will say, yeah. Yeah, let me just check what will happen if I just change this color to something. Which color should I choose? Maybe darker color. Sorry, sorry, darker color. Yeah, actually, darker color is showing me this line clear, but then darker color itself has some problem. Yellow. No. Mm, red. No. No. I don't know which color I should have been selected here. Uh, no. It seems that I should have selected some darker color, or it would have been better if this line would have been dark. Maybe I could have done that using the paint tool or something like that. No. Uh, okay, I think enough of trial and error. But anyway, I think this was a good puzzle. So I really like the idea of combining the. So these are all the standard variants, right? And it was just combined in the uh, what you can say intelligent way in Yang, as well as this circle and the triple duty circle. So each circle I was having 3 duties, and this 2 3 4 5 is also nicely placed. Just one thing is that I mean, if you do not assume that I mean, not assume that if this rule is not given that all the circles are on the path, then I think it is really great challenging. I don't know how will you proceed that. And on the Logic Master site comments also, I saw that it was mentioned that it is necessary that all the circles on the path. So I did that. The other thing person was saying is that somebody is that even if you are not given that circles on the path, if they are not on the path, then the value is 0. But I am not sure. I mean, I am not convinced with that. So I think that it's better that if you simply put that all the circles are on the path, so that will be better. But anyway, I think this was a great puzzle. Thanks to Apete. Peterson. Is this my first puzzle of Peterson? I don't know. I'll have to check. But anyway, thanks to the author Peterson, I really enjoyed this puzzle. This was a really good puzzle, and yeah, it checks my patience of doing Sudoku. Yeah, this somewhere here, right? If this is 2 7, it could not be possible. So I think that give some idea. And then 6 somewhere, right? I find out 6 somewhere, and then that 6 then give me way away. Otherwise, I was really quite stuck at that place. So yeah, so that's it. That's the puzzle. I hope you guys have also enjoyed it, and you guys were able to solve it. So thank you very much for now, and we'll meet again.